Finding trig values given information about an angle. All right, so we've built up a lot of information here. We've built up, you can just scroll back to the beginning here. We've built up this idea of reference angles and how the information we get in this first quadrant here might be enough information for us to talk about the entire unit circle while mostly focusing on the easier stuff, the stuff that happens in quadrant one. We said that reference angles, an angle and its reference angle will have the same value for a trig function, just potentially different signs. Um, so we're going to use that and do some fun stuff. I quite like this section. Like I quite like finding information about trig values when you're given information. So we're going to go back to the definition we had of unit circle trig, where we said sine was y, cosine was x, and tangent was y divided by x. And I want to talk about the signs of x and y first in the different quadrants. So this is going to be x and y, x, y, x, y, x, y. And I know these commas didn't turn out very comma-y, but make them look like commas. All right, in quadrant one, we know that x is positive and y is positive, right? This is positive y, positive x. So both of them are positive. And that means that sine, which is y, sine is positive in quadrant one. Cosine is the x value, and the x values are positive in quadrant one if the angle terminates in quadrant one. And tangent, it would be the y value, which is a positive, divided by the x value, which is also positive, and a positive divided by a positive is a positive. All right, so everything is positive in quadrant one. And here's the thing, the soulmates also follow suit with their soulmate. So sine's soulmate is cosecant of theta, right? Because it's 1 over y. And if sine is positive, so is cosecant. Cosine's soulmate is secant. So if secant is positive, so if cosine's positive, so is secant, and vice versa. If secant's positive, so is cosine. Soulmates do everything together. Tangent's soulmate is cotangent. So if tangent is positive, so is cotangent. So in quadrant one, everything is positive. All 6 trig functions are positive. In quadrant two, the x values are negative. These are negative x values, but they're positive y values. So sine, which again is y, sine is positive. The y value is positive. Cosine is negative because the x value is negative. Tangent is a positive y divided by a negative x, and a positive divided by a negative is a negative. So in quadrant two, only sine and sine soulmate cosecant are positive. The other ones, these guys here, they are negative. In quadrant four, I'll just write this down next to each of them. In quadrant four, our x values are negative and our y values are also negative. So sine, the y value, negative. Cosine, the x value, negative. Tangent, a negative divided by a negative, is a positive. So sine is negative, cosine's negative, but tangent is positive. Tangent and cotangent, of course. Finally, in quadrant four, x values are positive, but y values are negative. So sine is negative, the y value is negative. Cosine, the x value is positive. And then tangent will be a negative divided by a positive, which is a negative. So in quadrant four, only cosine and cosine soulmate secant are positive. I'm going to shrink these guys up just a teeny tiny bit here so I can make some notes. So in quadrant 1, I want to note that they are all positive. In quadrant 2, only sine is positive. Sine and sine's soulmate. In quadrant 3, I'll just do this down here. In quadrant 3, only tangent is positive. I'm just saving some room over here because I'm going to draw something over here real quick. And then in quadrant 4, only cosine is positive. Only cosine is positive. So we have this neat little trick that math teachers at some point came up with, and all math teachers have decided that we use it forever. We have this trick to determining which of these 6 functions are positive or negative in each of the quadrants. And it works like this. It works like this. All students take calculus. All students take calculus is the key to remembering this. So in the first quadrant, they are all positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. This, of course, is them and their soulmates, right? Because it's sine and cosecant is positive. I don't know why it keeps doing that. It keeps on doing a little thing. I hope that doesn't show up in the recording. A little loading sign. In quadrant 3, cotan is also positive. And in quadrant 4, secant. And secant is also positive. So we can use this to do some really fun things. Let's do a real simple one. Determining what quadrant the terminal side of an angle is in using information about the angle. So there is out there some angle and we don't know where it is. It could terminate in any of these quadrants. The only thing we know about the angle is information about whether it's positive or negative. So the first bit of information we're given is that tangent of theta is greater than 0. So this is saying tangent is positive. Greater than 0 means tan is positive. So if I go here and I do a all students take calculus situation and tangent is positive, that means that the angle can't terminate in quadrant 2 or quadrant 4 because tangent would be negative in those quadrants. And we were told tangent should be positive. All right, so now we just have to narrow it down to one more. The other information we were given was that sine of theta is less than 0. So that means that sine is negative. So we're choosing between quadrants 1 and 3. But if sine is negative, we can't be in quadrant 1 because everything should be positive in quadrant 1. We can also say it can't be in quadrant 2 because sine is also positive there. but we already had crossed out Q2, so I wasn't going to cross it out again. It only leaves one. There's just one left. Boom, quadrant 3. I'm not sure what theta is, but it does have to be in quadrant 3 based upon the signs of its trig values. All right, if you want an opportunity to try this one for yourself before I start going through the answer, go ahead and pause the video. All right, we're going for it. So first bit of information here, cosine of theta is greater than 0. That means that cosine is positive. What is that little cloud thing? All students take, you know what? I think I turned on a backup feature and I wonder if it's backing up. Weird. Okay, cosine is positive. So that means that it can't be in quadrants 2 or 3. The only ones where cosine is positive are in these two here, in the first and the fourth quadrant. Because cosine negative there. Next bit of information we're given is that cosecant of theta is less than 0. So we're saying cosecant is negative. And all students take calculus. The C here does not stand for cosecant. So this is a sidecast. Cosecant is sidecast. So we need to think of as main cast soulmate, right? So if cosecant is negative, then cosecant's soulmate, lover, partner in life, soulmate. I love love. Cosecant's soulmate, which is sine, will also be negative. If cosecant's negative, so is his soulmate sine. So sine must be negative. And if sine is negative, well, we can't be in quadrant, we can't be in quadrant 1. Hold on. I wrote something silly in my own notes. I was trying to figure out if I had made a mistake in this video or in my notes, and it's in my notes. All right, so theta cannot be in quadrant 1 because sine will be positive there. Theta not in Q1, or let's see, not in Q1. Also, we can also say if sine is negative, it can't be in quadrant 2, even though it's already crossed out. We could still say it, or Q2, because sine is positive there. That leaves us with one choice, quadrant 4, and that, boom, that's how you do it. I think it's a lot of fun. I think it's fairly simple, and it's soothing in a way, right? Just kind of follow the algorithm. All right, these next two are actually like, I love doing these next ones. So let theta be an angle in quadrant 2 such that sine of theta is equal to 4/9. Find the values of the 5 other trig functions. Okie dokie. There are many different ways to approach this. And let me tell you, if you go on the internet and you ask for help, you're going to find a bunch of different explanations. So you might have in high school seen a different way of doing this and able to do that method and come up with the right answer. And that is a-okay. There's many different ways. This is my way. I like to take care of signs first. So at the end of the day, we're looking at finding sine, cosecant, cosine, secant, tangent, and cotangent for this angle that we don't know anything about besides its sine value. So I like to take care of signs first. We'll set up signs based on quadrant. All students take calculus. We are in quadrant 2. So that means, sine of theta and his soulmate, cosecant of theta, those are the only two that are going to be positive. Cosine of theta and secant of theta, those are both going to be negative. I'm just going to put the negative there to begin with. And then tangent of theta and cotangent of theta. those also need to be negative because they're negative in quadrant 2. All right, that doesn't give us everything. We also know that sine is 4/9. That was given to us. That was part of the problem. And if sine is 4/9, cosecant is just the reciprocal of that, the flipsy-flu, if you will. So you just flipsy-flu it, and boom, we have cosecant, 9/4. So we just need to find the remaining 4 values now. And we do that by setting up a triangle using SOHCAHTOA and finding the remaining ratios. All right, I'm going to draw this triangle. You can draw whatever right triangle you want to draw, however you want to draw it. It does not matter. I'm going to put theta down here. Here's what we know. We know that sine of theta is equal to 4/9. Sine of theta is equal to 4/9. And with SOHCAHTOA, this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that means that the opposite side of this triangle is going to be 4, and the hypotenuse will be 9. So opposite 4, hypotenuse 9. This remaining side down here will be the square root of 9 squared minus 4 squared, which comes out to the square root of 65. So altogether, we have that the opposite side is 4, the adjacent side, so the side right next to the angle, but not the hypotenuse, so it's this guy here, that one is square root of 65, and the hypotenuse is 9. And you might think to yourself, Professor Cook, in this last section we did, section 1.3, didn't we say that the hypotenuse is always going to be 1? And so that is true of unit circle trig. When we talk about unit circle trig and we draw triangles that are inscribed within the unit circle, those will always have a hypotenuse of 1. But the thing about trig is that it's true of all right triangles. They don't have to have a hypotenuse of 1. Trig works for any right triangle. So this triangle right here, if we say that sine of theta is equal to 4/9, this triangle works for that. All right, we have these values. Now we just use SOHCAHTOA. So cosine is adjacent, which is square root of 65 over hypotenuse, which is 9. And then I'll do the flipsy-flu for secant. So that'll be 9 over square root of 65. And the negative is already taken care of because we did that before. For tangent, that's opposite over adjacent. So opposite is 4. Adjacent is square root of 65. So we have 4 divided by square root of 65. And the flipsy-flu, square root of 65 divided by 4. Of course, with the negative signs in there. And those are our answers. That's it. Boom, wham, bam, thank you, ma'am. All right, not so bad, right? Not so bad. You just have to organize your work. That's the big key here. All right, one last one for this particular idea. Let theta be an angle such that cotangent of theta is equal to -6/5 and secant of theta is greater than 0. Find the values of the other 5 trig functions. With problems like this, where you're given information, just start going for it. Here are the main things that are going to come in handy when you see any problem like this. You're going to want to know SOHCAHTOA. SOHCAHTOA is going to be important. You're going to want to know that all students take calculus. And honestly, between those 2 pieces of information, you can solve any problem. You're probably given all the information to use these 2 bits of knowledge and solve your problem. So for me, like I said, I'm going to determine the quadrant first. I like to determine sines first. Um, we weren't told the quadrant, so we need to find the quadrant, and then we'll use the quadrant to find the sines. All right. The information we were given, cotangent of theta is equal to -6/5, which to me means that cotan is negative. Cotan is negative. That's not what matters as much as, let me make this just like a different color, make it stand out a tiny bit. I don't care about cotangent because I want to look at this all students take calculus thing. So I care about his soulmate, the soulmate. Cotangent soulmate is tangent. So if cotan is negative, so is tangent. And if I'm looking at all students take calculus and tangent is negative, if tangent's negative, it can't be in quadrant 3 because tangent's positive there, and it can't be in quadrant 1 because everything's positive there. So it's not Q1 or Q3. The other information we were given is that secant of theta is greater than 0. So that means secant is positive. Uh, all students take calculus. We need to switch it to its main cast friend. So secant soulmate is cosine. So if secant is positive, so is cosine. So if cosine needs to be positive, it can't be in quadrant 2 and it can't be in quadrant 3. That leaves us just with quadrant 4. So we know that this guy is in quadrant 4. So we'll set up those signs. Like to give a little bit more room here, cosine theta, tangent of theta, and we have sine soulmate is cosecant, cosine soulmate is secant, tangent soulmate is cotangent. In quadrant, in quadrant 4, cosine is the only one positive, so cosine and secant, those will both be positive. Everyone else, so sine and cosecant, tangent and cotangent, they are negative. So I'm just putting their negative signs in. Once we've done this, we don't have to think about things being positive or negative again. We can just ignore the negative and do SOHCAHTOA in a triangle. Triangle and SOHCAHTOA. And you can ignore negatives here in this triangle. So technically, cotan of theta is -6/5, right? It's -6/5, but I'm just going to ignore that negative sign. And first of all, let's switch him to his main cast friend. So cotangent's main cast friend is tangent. Very technically, we would say like tangent of theta is equal to 5 over -6. I'm not going to use that negative sign anymore. I'm going to pretend it's not there anymore. Tangent is opposite. So opposite is 5. over adjacent. And here's where I ignore the negative. Boop, 6. I'm just ignoring its negative. We don't need to worry about that. No need. Set up a triangle. Here's theta. Our opposite side is 5. Our adjacent side is 6. Our hypotenuse is going to be the square root of 6 squared plus 5 squared, which is the square root of 61. So opposite is 5, adjacent is 6, hypotenuse, square root of 61. All right. We can start filling in over here. First of all, cotangent was given to us. Cotangent was -6/5. I'm going to put that in. The negative's already there, so -6/5. And the flip-C-flu for tangent, tangent is -5/6. Those are done. SOHCAHTOA for sine, sine is opposite over hypotenuse. Opposite is 5, hypotenuse is the square root of 61. The flip-C-flu for soulmate cosecant, cosecant is going to be negative square root of 61 over 5. For cosine, cosine is equal to adjacent over hypotenuse. So adjacent is 6, hypotenuse is the square root of 61. And secant is equal to the flip-C-flu of cosine. So that'll be square root of 61 over 6. And that's that. So I find that students tend to struggle on these types of problems, but I, I hope you can see if you lay out your information, it's truly a very straightforward process that uses really two base pieces of knowledge here. Two base pieces of knowledge, I mean, and a Pythagorean theorem as well, but it gets you all the way there. I think it's a lot of fun if you let it be, and I hope you enjoy it. All right, in the next video, we'll talk about finishing off that unit circle, filling it all out, and that'll be it for section 1.4. I'll see you in that video. Bye.